Okay, so now that we're on the review page, I would like you to get into groups and attempt these problems, but you will go through it with the video. So you will take a look and begin the first one and pause the video, work with your group to see if you guys can come up with a solution, and then turn the video back on to see how you did. Now, when you are solving these, I want you to leave your answers as exact answers. I do not want any decimals. Okay, so hopefully you went ahead and you set one side equal to 0. Again, I told you my strategy is to always keep the x squared positive, so I added the 8x and subtracted, let's see, I'll slide this over a little bit, subtracted the minus 11 from both sides, and you should have ended up with 5x squared plus 8x minus 11. There would be your A, B, and C. And then you're going to end up with something like this, and you're going to end up with a 284 underneath. Now, even if you didn't so add 8x and subtract 11x, you might end up with a positive 8 out here and a negative 10. That's fine, but you should still end up with a 284. Now, if you try to take the square root of 284, you're going to see it as not a perfect square, and I don't want a decimal answer. So this goes back to what we did last week, where we have to break that down. Now, the first largest perfect square smaller than 284 is 256. That's 16 squared. So you need to go through and, starting at the largest square, work backwards until you find the first largest perfect square that goes into 284. And if you keep working that out, you're going to see that this is going to break down into x equals the negative 8 plus or minus, and we are going to have the square root of 4 times 71 all over 10. Now, as we break that apart, we can break out this 4. The square root of 4 is going to break out as a 2. So when I rewrite this, I'm going to go up here. X is equal to negative 8 plus or minus 2 root 71 over 10. Now, you need to go through and you have to reduce this. This is not in final form. Now remember, this is two fractions. This is really negative 8 over 10, and it's 2 root 71 over 10. So you would have to divide the 10 into both of these terms. So you could split it up into the two fractions, or you should know that the 10 would go into both of them. I'm going to show that it's split up just so that you can see the picture of that. But basically, you're going to reduce negative 8 over 10. Again, we don't want a decimal. Negative 8 over 10 will reduce to negative 4 over 5. And then you're going to reduce 2 root 71 over 10. That's going to reduce down to root 71 all over 5. Again, it would be 1/5, but we don't have to put the 1 out in front. Our final answer, we put this together, would be negative 4 plus or minus root 71 over 5. Now, because these both would have reduced down to 5 over here, we could have just put it going straight from this problem right here. Negative 4 over, this would become 5, and then 2 over 10 becomes the 1/5. So that's where we get negative 4 plus or minus root 71 over 5. And again, we're looking for exact answers. Okay, pause the video and try number 2. Okay, so for question number 2, if you did it correctly, you subtracted 3 from both sides. You should have identified your A, B, and C, and you should have ended up with a 28 over here. And when we do this, we can break 28 down into 4 times 7. So this will break out as a 2 and leave a 7 underneath. So we have 2 plus and minus 2 root 7 all over 4. Now again, we need to divide the 4 into each term. So if you go ahead and do that here, this is going to reduce down to 1 over 2 as well as 1 over 2 here, and you can be done and say it's 1 plus or minus root 7 over 2. If you struggle with that, you can break it apart into the two fractions, putting each one over the common denominator of 4, reducing it, and then putting it back together. Okay, so continue on with number 3, and I want to make this comment. I think it's really important to leave the A term as positive, because if you decide to make your A term as negative, what's going to happen is when you use your quadratic formula and you end up with 2 times A, If it's negative, you're going to end up with a negative under here, and the issue will become when trying to reduce. If you have a negative under here, like for example, if this had been a -2, let's see, where was I at here? If this had been a negative, okay, go back up to here. If this had been a -4, students sometimes will get confused on how to reduce this due to the plus or minus sign. Okay, because even though it would have been a -4, we still would reduce it to a +1/2 because of the plus and minus sign. So my strategy is to always keep the A term positive, and I think it'll just make everything a lot easier for you. Okay, so go ahead and solve this one, pause the video, and then turn it back on. Okay, so let's see how this one went. So hopefully you added 4x and subtracted 7 from both sides. And if you did that, you should end up with right here, -4 plus and minus the square root of 128 all over 8. Now 128 can be broken down into the largest perfect square of 64 times 2. Now I went up here and I rewrote that. I took the square root of 64 to get 8. So I have -4 plus or minus square root of 8 over 2. So plus or minus 8 root 2 all over 8. Now, we know that both of these will go, are going to get divided by 8. But if we take a look here, they're not going to reduce to a common denominator because -4 over 8 will reduce down to -1/2, while this will reduce down to just +1. So you have to be careful of that if you are doing it this way. So if we were to think about this, this will simplify into -1/2 plus or minus square root of 2. And that would be my answer, okay? But we would also see if we were to have gone through and broke that up into the two fractions, for those of you that struggle with seeing that, the reason that answer happened is because of the fact this is all over 8. This breaks down into the two fractions, so this would be -1/2 plus or minus, that divides out to be 1, and if it's just 1 out here, I don't need to write that, square root of 2. So you can see that's where I came up with this answer. So if it doesn't reduce to the same denominator, you do have to split it up into two terms. Okay, pause the video and try example 4 with your group and see how you do. Okay, so let's take a look at the last example. Hopefully you started by adding the 22 to both sides, identified your A, B, and C, and you should have plugged it in. And when you did, you should have come out with a -336 underneath. Now, when you see you have a negative radical, one of the things that I like to do when using quadratic is to pull that negative sign out as the I. So I end up with this right here. Now you're going to go through and break the 336 up into its largest perfect square, and we have 16 times 21. And when we take the square root of 16, that's going to become 4. So x is going to be equal to -4 plus or minus 4i root 21 over 8. And now again, the final answer needs to be reduced. We would be going through, and we see because these are both the 4 over 8s, they're going to reduce down to a common denominator. So -4 over 8 reduces down to -1 over 2. Plus or minus, this would be 1 over 2 again. But when it's a 1 in front, we don't have to write the 1i. So this would be I root 21 all over 2. Okay, so again, the next level in Algebra 2 with using quadratic formula is now you have to not just leave answers in terms of decimals because those are not exact answers. You need to be able to give exact answers, and if it's not a perfect square and can be broken down, you need to break that perfect square down, as well as finding solutions when you have non-real solutions. All right, have a great night.